welcome to the Los Angeles Data Platform. This is perhaps the first time that I'm saying Los Angeles Data Platform without saying SQL Mobile before that. Today we have a presentation, Aurora MySQL Deep Dive by Vijay Karumajji, right?
Yes.
Perfect. And today's session is, today's meeting is sponsored by Redgate. We have already few people joined, and I'm going to turn it to Vijay. Nice to have you, and it's going to be really interesting to hear something that is not SQL Server for change.
Sure. Let me share my screen once we're done. Can you guys see my screen?
Yep. Send Dunes again.
Hey guys, I'm Vijay Karumajji. I'm a specialist database solutions architect, mainly focus on RDS, MySQL, and MariaDB and Aurora MySQL family. Before AWS, I used to work as a SQL Server DBA. I have around 15 years of IT experience. I've worked as a SQL Server DBA developer and then done some Microsoft development programs as well. So today's topic is Amazon Aurora MySQL, mostly concentrating on MySQL family, but all the architecture and everything also applicable to Amazon Aurora Postgres DB engine as well. So if you have any questions, feel free to ask or unmute yourself and ask, because I don't see we have a lot of people join. So let's make it interactive session. And if you want to keep your questions at the end, I'm going to take the questions at the end as well. So Amazon Aurora is before we go talk about Amazon Aurora today, I'm going to talk about fundamentals of Amazon Aurora, how it is different from other database engines with respect to the architecture, and then what are the high availability and DR scenarios we have in Aurora. And I'm going to show you what are the monitoring tools and security best practices as well. And then why Amazon Aurora is performing much better than other database engines what we have. And then I'm going to show you if you're planning to migrate any of the database engines to Aurora MySQL. I'm going to show you what are the tools you can use to migrate to Aurora. So when we designed Aurora, we had few things in mind. We want to provide speed and availability of the high-end commercial database engines like SQL Server and Oracle. And then at the same time, we want to provide simplicity and cost effectiveness of the open source database engines. So that's what we had in mind. That's why we developed this product. And then Amazon Aurora has a drop-in compatibility with MySQL and PostgreSQL. So Aurora has two flavors. One is MySQL and PostgreSQL. If you have applications, if you're already using MySQL, if you want to use Amazon Aurora from the application point of view, you don't need to do any changes. It is mostly compatible with MySQL and PostgreSQL. And it has a pay-as-you-go pricing model. So whatever the storage you use, you pay for only that storage. And I'm going to talk about what is pay-as-you-go pricing means down the line. And then when we designed Aurora, we had three things in mind as well. So one is we want to give you a scale out and distributed design architecture. I'm going to show you how the traditional architectures looks like. And then I'm going to show you what a scale out distributed architecture is. So that is what we have changed in Aurora. We did a scale-up distributed relational database engine. And then if you're already using AWS services, relational database engine also have tightly integration with other AWS services. And it provided as a fully managed service, so you don't need to worry about administrating tasks. So when we talk about cloud ecosystem and Amazon Aurora, in AWS, we have services like Lambda and S3, identity access management for security and CloudWatch metrics we have, and then we have Amazon AI/ML services like SageMaker and Comprehend, right? So all these Amazon with Aurora, you can leverage all these services from relational database point of view, right? You can invoke a Lambda function using your stored procedures and triggers. So you have a Lambda function call, you can do it. And then we take backups to Amazon S3 continuously without any impact of your application. So all the backups goes to S3 storage. And also you can load files from S3 and load files to S3 as well. And also we have integration with identity access management, which is an identity access management as a different service where you can use identity IAM roles to access your relational databases as well. And also we provide you all the monitoring metrics like database metrics, OS level metrics, everything you can see in the CloudWatch. So you can push all your logs like slow query logs and audit logs, everything logs, all the logs you can see in the CloudWatch. And then we recently announced last year integration with SageMaker and Comprehend. So if you have any applications you want to do some predictions on your relational data, you can do it using Amazon SageMaker and Comprehend services. So even calling an AI/ML services, right? You can simply do it using a simple SQL calls. I'm going to show you how it looks like in our further presentation. So when we talk about a managed service, right? What does it mean? What it means is we take care of like routine maintenances, like providing monitoring tools, right? Doing patching for you, and then we will give you push button scaling for the read activity. If you have applications which has a lot of read activity, you can do the read scaling as well. And then AWS infrastructure by default comes with industry compliance. We have third-party assurance frameworks which are already there. So we have all those compliance already pre-approved for the AWS infrastructure. And then we have isolation and security tools available for you. So you don't need to worry about backups and recovery and failovers. In case one of the availability zone goes down, then availability zone is nothing but a data center, right? One of the data center goes down, you still have your databases running in other data centers. So from your application point of view, you still have full availability of your databases. So you don't need to worry about all those right side part of the things, right? You take care of things what is really brings value to your business. Like you want to improve your application performance, you want to write the queries properly, you want to optimize your queries, which brings value to your business and which eventually brings value to your customers. So that's what we take care of. So that's why we have seen a lot of fastest growing service in AWS history. So one of the Aurora is used 3/4 of the top customers. So you can relate, these are all these customers from different verticals of the business using Aurora.
Vijay?
Yes.
If you can go back to slides, please. So then you mentioned routine maintenance. Yeah, one more slide.
Yes.
Routine maintenance. Does that include
Sorry, your voice, I can't hear you. I can't hear your voice.
Maintenance includes also stats or not?
Sorry?
Does routine maintenance, is it including work on indexes and work on statistics?
Yeah, statistics and update stacks. If you're coming from SQL Server background, right? Yeah, we provide an option to configure your statistics as well. Yes.
And this is done by.
Sorry, your voice is really breaking down.
Yes, it's done by routine maintenance. So there is nothing that we need to do.
Yeah, some of the, if you want to do some of the update your statistics, or you want to see system level configurations if you have to do. There are MySQL commands which are available for you. You can run those commands too, right? For example, if you want to update a specific, how many number of pages you want to scan through before you get in cost estimation of your specific query. So you have a parameter groups where you can configure, which I will talk about in the further presentation in the monitoring section, where monitoring and management section, how you can manage your databases. But yes, for your question, yes, we have all those facilities.
Okay, thank you.
So what we have seen, customers adapting Amazon Aurora is customers migrating from open source database engines like MySQL and Aurora, MySQL and PostgreSQLs, because for the high performance and better availability. And then we also have easy migration tools. And also we have seen commercial database engines like SQL Server and Oracle customers are migrating to Aurora because they want to decrease the licensing cost. And at the same time, they get the better performance of same or better performance like commercial database engines. And we have migration tools available. So I'm going to show you those tools in this session as well. And then I also seen customers who are building totally new applications directly in AWS Cloud using Amazon Aurora because they can they can integrate with other AWS services easily, and which provides them better scalability and availability, and they don't need to worry about managing the databases. So now that is over. So now we are going into what is the core architecture looks like and how it is different from traditional database engines, what we have seen so far, right? If you think about database engines like 40 years ago, right? Databases are all about I/O, right? You have to increase the bandwidth, and then if you decrease the number of I/O consumptions on your database engines on the compute node, then your databases perform well. But if you see the stack looks like compute node looks like you have a SQL layer, transaction layer, caching layer, and logging layer, which is attached to a storage subsystem. Hopefully it's fast storage, right? This is how it used to look like in traditional database architecture. Now the same traditional architecture moved to cloud, it looks like something like this. But if you look at the compute node, right, you still have the SQL layer, transaction layer, caching layer, logging layer still there. And then now it is attached to a storage subsystem. And then pipe decreased small because in the cloud we have seen instances fail and they get replaced and then they shut down, and then you can do scale up and scale down of the compute nodes, and then you do scale out of your computes, right? So you have different options and different things you can do in cloud. So most of the operations what we do, because we believe in longevity of the developers, so that they can do and shut down the instances when they don't use it, so they can do some cost savings on their in the cloud, right? So, but end of the day, the compute node looks the same. But when we move to the Aurora, so where we spend a lot of time in, if you look at the compute node, right? For example, if you look at the writer, the SQL layer, transaction layer you have, and the caching layer you have. And then we don't have that logging layer. What does that logging layer do is we move that logging layer to the storage. So if you look at the storage, Aurora storage, now you have a storage which spans across 3 availability zones, but you would see a shared cluster storage volume. That is the view of the database engine. That's what the MySQL process looks into. But behind the scenes, you have different storage nodes. Those are mostly a compute I3 kind of instance classes, easy to compute classes instances you have. And then we put the data into all the storage nodes across 3 availability zones, and each availability zone will have 2 copies of your data. So, and then each storage node will hold 10 gigs of chunks, right? So if you have 100 gigs, you have 100 different storage nodes you have in one availability zone, and then you have 2 copies. That means you have 200 storage nodes only in one availability zone. And then total 3 availability zone, you have total 600 storage nodes. So your 100 gigs of data spans across 600 different storage nodes, right? And then other difference is you only pay for the storage nodes for only one copy. You don't pay for other copies. We maintain that for you to provide you the high availability. And also you have read replicas also pointed to the same storage node so that you can scale your reads between your writers and then readers in an Aurora cluster. So whenever there is an application comes in, talks to the Aurora cluster, you can tell, hey, this is a read query, send my workload to the reader. And then if it is a write query, you can send it to the writer. So you have that capability. And then also we provide you an AZ plus one failure protection for your data. So in case whole data center AZ went down, you still can have access to your data. So whenever we write something to the database, out of these 6 storage nodes, because one copy will have in 6 different places, right? So first we have to make sure that if you're writing something, at least we have to write 4 of the storage nodes out of these 6 copies of your data. So as long as we write four storage nodes, your write is persistent in Aurora. For reads, we do 3 out of 6 quorum model, we do it. So both master and read replicas points to the same storage. That's how we write it to the storage. But I will tell you what we write is whenever we are writing to the storage nodes, right? Normally, if you are coming from SQL Server background, right? Whenever you write something to the database, you write it to first cache. You want to make sure your data pages are in the cache. If it is in the cache, then you update the cache, and then you do a checkpoint or lazy writer kicks in, and then you flush those dirty pages to the storage, right? In Aurora, it happens differently. What we do is, because we move that logging layer to the storage subsystem, we don't need to generate the pages in the cache. So if you're writing something, all we do is we capture that redo log, and you can think it as a transaction log, right? We send that log directly to the storage subsystem. And then once we get 4 out of 6 a quorum, then your transaction will process to the next transaction. So instead of writing full data pages over the wire from the compute to storage, we just write redo logs. So basically redo logs are before page of the image and after page of the image. For example, if you're modifying few columns in a row, right? In traditional systems, you have to take that full page, and then you have to update the page, and then you have to write the page. In Aurora, those few columns might be few bytes, right? So we simply write those few bytes to the storage subsystem. That's how the write happens in Aurora. When we are writing this, now we wrote the data to the storage. At one point of time, for your read queries, we need to make sure because MySQL process or SQL Server, any processors, database processes, right? They can understand only data pages. So that's why what we do behind the scenes is we build the data pages in the storage layer asynchronously. So it does not impact performance of what you're writing into the Aurora at all. So that's how the write works. And whenever you're reading from the reader side, right? Because you can have up to 15 read replicas in Aurora cluster. So same storage system, you can have up to 15 read replicas. So within that read replicas, right? If you have a select query coming up, you can tell you will get a data page from the storage subsystem, or if the data page is already in the cache, you get it from the cache. So that is the storage architecture, and then we have some parameters you can use in your application to make sure you can split the read and write between the writers and the readers. In MySQL, we have an option called InnoDB read-only option. So if it's in your application, before you're sending a query to the cluster, you can see, is it InnoDB read-only? If it's an InnoDB read-only, send it to my reader. So before you send it to the reader, Aurora provides you 2 different endpoints by default. by default, you have a cluster endpoint that always points to your writer. So, and then you have a reader endpoint, which always points to the reader. So that's how you, from your application, you utilize these DNS endpoints, and then you do reads and writes in Aurora cluster synchronously, and then you can push a lot of data. So Aurora performs much better whenever you do have a lot of concurrent connections which are pushing the writes. A lot of writes you're doing, a lot of reads you're doing, because it can process all the heavy writes because of those redo log changes. What we did, we pushing that log applicator to the storage subsystem. So I'm going to take a break and then see if we have any questions here on the Aurora storage point of view, how the storage is operating, how reads and writes are operating.
Couple questions. So first one, like you said, you don't save pages, only changes to the page. What happened if you need to split page?
It's a simpler redo log, right? If we don't, why do you want to split the page?
Well, the data is like you're updating data. It used to be empty string, and I put in 800 byte scripts string. So it's not fitting page anymore. Something like this.
Yeah, for example, blob columns, right? For example, just an example, you storing a image in your tables, right? Storage are all the blob columns. They're also they're not part of the data pages.
No, it's not. It's not about blob. It's about, for example, you have a page, right, and you have a simple string in the page. So you have 100 records in this page, right? And records is full. And now you update one field, instead 10 byte, you put, like if it's varchar or something, you put 1,000 bytes. And now you're out of space on the page.
And you have to split the page and write it to a different page, right? So that we take care of it. But you don't see that because you have to do that if you have a traditional system, right? You have to do that on the fly. In Aurora, we don't do it on the fly. We do it asynchronously behind the scenes. As long as you write the transaction to the using that redo log files to the storage subsystem, your transaction is completed. That means your data is persistent on the storage. And then behind the scenes, the log applicator will take care of all the splitting the pages if it has to. If there is a lot of data, it may need to provision new storage node. It will take care of that too. If your data is growing, it will take care of adding new storage nodes as well.
And you keep saying that we like Aurora eliminate transactions log, right? But you keep mentioning redo log. Is a redo log and transaction log, it's not basically the same purpose, the same thing?
Yeah, more or less the same thing, yes. That is, in a SQL Server, you call it transaction logs. In MySQL, you call them redo logs. And in MySQL, you also have a binary logs that acts as real transaction logs. But in Aurora, you don't have those binary logs.
So basically, this redo log, but you still have redo logs with the data, right?
Correct.
And it's stored on shared cluster storage volume, or it's on a disk. I don't know what's the difference.
It's saved in the storage nodes, shared cluster.
Okay. Thank you.
Yeah, sure. So now that we talked about reads and writes, and then the storage nodes, right? So there is also a concept called replication lag. Because even though we use the same storage, there will be a replication lag because we have to update the reader cache to make sure that the reader cache is also updated. For that, we send the same before page of the image and after page of the image, the same redo log to the readers. If the data page related to that redo log change exists in the reader cache, then we will update the cache of the reader. So the amount of time it takes to update the cache is the replication lag you normally see from the compute point of view. So that's why you see a replication lag. So now let's talk about some performance features and optimizations what we have in Aurora. We did some synthetic sysbench. MySQL community uses the synthetic tool, which is sysbench tool. We did the performance analysis between RDS MySQL 5.6 and 5.7 and MySQL 8.0 versus Aurora 5.6 and 5.7. We have seen better throughputs in Aurora. At least if you look at it, you would see at least 5 times better throughputs in writes, and then you would see better throughputs in the read throughputs. This testing, synthetic tool testing, we have published an article blog as well. So you can also produce the same synthetic tool. You can also run it on your on-premise or on your location on your AWS account, and you can see the results as well. But this is what we have seen. We have seen better throughputs. And whenever there is performance variability under the load, right? Aurora MySQL is 25 more consistent under the load than normal MySQL what we have tested. If you see, there are some spikes in MySQL because it has to wait for a checkpoint to happen. When you do the checkpoint, then you would see some spikes in your application latencies. But in Aurora, it constantly performs because Aurora, we don't do any checkpoints at all. We simply write it to the storage subsystem. And this is a little bit deep dive in MySQL and Aurora MySQL. So I'm trying to see what in traditional systems what we write. So if you follow on the left side, you see one master and then one read replica, which is a secondary. This is we compared in RDS MySQL multi-AZ scenario. That means two instances have its own storage subsystems, and then it is going to write log files, binary log files, data logs, and in MySQL you also have to write double write buffers, and then you have to write the information about FRM files. Whenever you open a table, whenever you close a table, you have to write it in the FRM files, right? So you have to write quite a lot of pages, quite a lot of data into the volumes, EBS volumes. So if you see it here, if you do a transaction, you have to write it to number 1, and then you have to send the same information, same data to your replica, which would be your secondary instance, and then you have to write it to the EBS volume. And also we do mirroring of those EBS volumes, so you have to write it to the mirrored EBS volume. As long as you do number 1, 3, 4, and 5 in multi-AZ scenario, then your transaction is committed. Once 1, 3, 4, and 5 is done, your transaction is committed, and then you will proceed to the next transaction. Because you're writing log files, binary log files, data log files, you do have a performance impact, and you're also writing a lot of data pages. So when we did performance analysis between these two, RDS MySQL versus Aurora MySQL, in Aurora, as we write only the simple redo log files, and then we have to write it to 4 storage nodes out of 6, then while we did the performance analysis, we have seen using sysbench runs, what we did, we have seen 35% more transactions we could process in Aurora compared to traditional systems. At the same time, if you think about reading point of view, right? If you see read replicas, normally if you have a read replica, what you normally do is you have a DB master and then DB read replica. Whatever you write here, you have to send the same transaction log, and then you have to replay here on the read replica. So basically, a lot of customers use read replica to serve read activity for your application. But in traditional systems, what happens is you have to rewrite all the transactions on the read replicas. So you only using your actual read replica, only 30% of the read replica you're using. But in Aurora, because it has the storage structure, what we have, right? You don't need to replay the transactions at all. Once you send it to the storage subsystem, you have a capability to have 15 read replicas. All those read replicas will have access to the same storage, but we have to, as we discussed, we have to update the read replica buffer cache because you don't want to give the wrong data to your applications, so stale data to your applications, right? So rather than do, that's why we will send those same redo logs and update in the read replica cache. And when we come to Aurora performance, whenever you're migrating from traditional systems to Aurora systems, we already pre-configured your instances, computes for the type of the instance you're using. If you're using 2x large or 4x large or 8x large instances, these are instances have a different CPU and memory, right? All of them. So if you are coming from on-prem or from RDS MySQL or AWS MySQL you're using on EC2, if you have a MySQL, right, you have your own configurations. Just like in SQL Server, you have sp_configure, where you configure a lot of configurations for your databases, right? So same configurations, when you coming from SQL Server or MySQL, you don't need to configure anything because we already pre-configured those configurations for you. Depends on the compute instance classes what you choose in Aurora. So whenever you do performance test, we always recommend customers to test it with default configurations. And then if you want to do, if you think that your application would get more benefit out of configuring a specific parameter, then you can configure your parameters in Aurora. But by default, we do say that don't configure, just go with the default parameters. And then we talked about, we do fewer IOs. That's why you would see performance. And other performance enhancements, what we did is, there are two things, Amazon Aurora Parallel Query and then machine learning. So let's look into Amazon Aurora Parallel Query. What Parallel Query means is you have the storage node, and storage node has different hundreds of storage nodes, right? Aurora storage. So whenever you have a workload, something like OLTP or also some analytical workloads you have, right? So still majority of your work is OLTP, but you have some reporting analytical workloads as well. In traditional systems, what we have seen is whenever you run these analytical workloads, you would see performance degradation in your OLTP systems of your application. So Aurora has a parallel query feature where what it does is it will take the query and then sends that query to the storage nodes, like aggregations and push down predications, which will automatically detect because you have created the parallel query cluster. Whenever you're creating Aurora cluster, you choose that I want this parallel query cluster. Whenever you do this, we push down these aggregations and predicates to the storage nodes, and then we will compute the storage nodes. We will do the heavy lifting at the storage nodes, and then we will push down the results to the Aurora main writer cluster. So that's where you would see better performance. And also you can see in your execution plan you can see if that a particular query using parallel query feature or not. And each instance has a number of threads which are available for the parallel query to do its stuff with the storage nodes. So whenever you have a bigger instance, then you would see more parallel threads in Aurora Parallel Query, then your workload would perform much better. And then we do parallelize between all the storage nodes of computing for your analytical workloads. And then there are, of course, there are some limitations. You cannot have a row format compact. We will only use compact row format in your, whenever you store the data. In MySQL, you have different formats where you load the data into the table. Some tables you can also do compressed as well, right? So, but it will only support compact, and then it has some restrictions in backtrack features, all performance insights you cannot have. So if you want all those things, then parallel query might not be a good solution for you. And then currently it is only available in MySQL 5.6 Aurora cluster. So if you're looking for 5.7 MySQL, then parallel query won't be there in MySQL Aurora MySQL 5.7 as of today, but it might change. And we have a use case where Netflix used Aurora Parallel Query compared to traditional Aurora MySQL cluster, and then they have seen better performance in the peak speed in their application if compared to Aurora traditional cluster versus Parallel Query cluster. Any questions before I talk about Aurora machine learning?
So perhaps if you can sum up in one statement the difference between RDS MySQL and Aurora MySQL.
Mm-hmm.
What would be the one sentence difference?
It's quite a lot of difference in RDS MySQL versus Aurora. I cannot sum up in one sentence, but there are a lot of differences. For example, I showed you previously, right, one sentence. Let me go back here, right? This is RDS MySQL, and where you have to enable binary logs, you have to take care of the binary logs, and you have a double write buffers in MySQL, which is not there in Aurora MySQL. And then you have a binary logs needed for the RDS MySQL, but in Aurora, it does not need binary logs because the architecture is changed. And then binary logs are needed here for the recovery process. In Aurora, we don't care about binary logs for the recovery process. And then a lot of configuration, storage level configurations available, which you configure in your myconfig file in RDS MySQL, traditional MySQL as well, right? So, but you don't need to worry about those configurations in Aurora. So there are quite a lot of differences.
And so storage system is different, or storage engine is different?
In Aurora?
Yes.
Yeah, so in RDS MySQL, you have block level storage, EBS volumes, right? If you're running your MySQL in RDS, but in Aurora, this is not a block level storage. It is a log structured storage. That is one of the main difference.
Got it.
And then talking about Aurora machine learning, right? So we have introduced Aurora machine learning. You can call from Aurora, you can call machine learning services. So if you want to do predictions on your relational data, you can do that. I'm going to show you what is a predication means, and I have a T-SQL query which I can show you. All you need to do is simple T-SQL query you need to run, and then that will call machine learning services, and then you will get your data. So why do you want to do this, right? We have integration with SageMaker and Comprehend. Those are the two currently supported for Aurora MySQL, but we're still working on other machine learning services. But end-to-end data from machine learning to Aurora to all the way up to application is totally encrypted. So you can do the encryption as well. So when you normally run machine learning models, not in relational database, if you think about not relational database, so you launched a product, and that product, you're getting feedback of that product. For example, right, everyone giving you feedbacks on Twitter, everyone giving you on Facebook, and everyone giving you a lot of data you're getting. You have all the data in your relational database. Now you need to find out by looking into that data, you have to tell if your product is success or failure. So if you want to do some kind of predictions like that, in traditional systems, what you have to do is you have to take all the data, put it in one location, and then you have to write you have to ask a data scientist to come in, and then he has to work on models, AI/ML models, and then he has to run the data, and then he has to process all the data using that AI/ML models they develop in Notebook or Jupyter Notebook or something, right? You take the data and then you put it in your traditional database engine, and then you supply that whatever the model give you output, that data, you give it to your application. Then to do that, it has basically an offline operation. It's not within simple SQL query. You can't access it. You have to do it offline, and you have a downtime for that to analyze data. But with Aurora, what you can do is you can simply write a T-SQL query. The first option is you have the model within your AML service, and then you run a simple query in your T-SQL query in your stored procedure, and then that will go and talk to model, and it will process that model and get the data, and that data will be given it to you straight away, immediately to your application. So you can immediately tell the prediction of that particular product, what you're trying to do the predictions. How it looks like in real time is a simple, I just came up with few T-SQL queries. For example, you are a banking company, and before you insert a check into your sales table, right? You want to see if it is a fraudulent transaction or not. So this is transactional fraudulent is a model in your AML service. So you're simply calling that service and sending the data. If it is true, you roll back. If it is not true, then your application will continue processing the data. Same way we talked about product reviews, right? You have all the data in your relational data. You simply call AWS comprehend service, and then there are already a lot of models already there for you. You can use your existing models, which are already there, or if you want to create your own model, you can create in your AML service. Keep your models in the AML service. Here, I'm just using the already existing sentiment model, detect sentiment. I just pass my column review text, right, as a parameter to your model, and then I will get the output immediately. So your application can take that output and then process next business logic. So this is just an example. I just want to show you we have highly integrated the AML services. Any questions?
Vijay?
Yes.
So there is a question from Arvind. Question on ML services integration. Is the SQL native ML capability is for scoring invocations, or are there broader training scenarios also supported within SQL syntax?
So if I understand correctly, are there any other models available? Right now we have SageMaker and Comprehend is the only two ML services which are available, compatible with Aurora.
Wait a second, he is typing. Okay, yep, he's saying thank you.
Okay, so now before we talk about high availability features in Aurora, performance only matters if you have databases up and running, right? So let's see what is the high availability features we have in Aurora. So we have in Aurora, we have quite a few survivable AZ+1 failures, right? In case if your data center is down and one of the storage nodes down, how it looks like, and continuous backups. These are all we're going to go over all these 9 topics, high availability topics. So if you look at it, storage nodes spans across 3 availability zones, and each availability zone have 2 copies. And then for you to do a write quorum, then for you to do a write, you need at least 4 storage nodes needs to be up and running. So in case there is a whole availability zone went down, you can still do reads and writes in your application without any impact of your application. So your application does not even know there is some problem here at all. If you have AZ plus one of the storage node went down, that means you have end up with 3, right? So at that point, you can only do read availability, because when you have a lot of storage nodes in your Aurora cluster, right? There are some background radiations always happen. Switches fail, and then you have a maintenance has to do. You don't even on a daily basis, you don't even notice, because just going down one storage node does not even impact your Aurora cluster. That seamlessly happens without having any impact. And all the storage nodes talk to each other as well with Amazon Aurora Backbone Network. They repair themselves as well. So in case one storage node is down because of some data issue or some data thing, it can borrow from other storage node, and it can update by itself too. So it has a tolerance with AZ+1 failures. And then other thing is we continuously take backups from each and single storage node, continuously take backups and put it in S3. So you don't need to worry about backups, because some of these systems you have seen, if you take a backup, you have to freeze an IO and then take the backup and then start your application. During that few seconds, right, even 1 second, you might see an application degradation performance, right? In Aurora, you won't see that at all. Continuously, we stream those logs and snapshots to S3. And then whenever you restore, because we take all the logs continuously, right? Whenever you restore, you can do point-in-time restore as well, because all these transactional logs, we take backups every 5 minutes, right? So continuously streaming, and then every 5 minutes we have. So in case if you want to go back, you can go back within time less than 5 minutes, almost 5 minutes. So you can do point-in-time restores up to 5 minutes. And then this is one of the backtrack feature we have within the same Aurora storage. So if you look at the slide here, right? For example, this is the time frames I put it for storage nodes. So at T1, someone accidentally deleted the table, right? And then time went by. At T2, you realize that there is a table missing. Then what you're going to do? In traditional systems, you have to restore the last night snapshot or backup, and then apply all the transaction logs and then get that table, right? In Aurora, what you can do is, if you enable this backtrack feature, you can simply, within the same cluster, you can simply move the cursor from T2 to T1. You can move it within few seconds, few minutes, basically. So you can simply go back in time and then take the table, which one got deleted, take the table back up. And if you can lose, because normally in production systems, you don't want to lose data between T1 and T2. So you can, once you take the backup of the table, you simply move forward. And then when you are at T2, you can just simply restore the table back. So you have that kind of accidental deletions. You have production in Aurora, and it gives you better availability of your data as well. And also, there are some use cases you created in Aurora cluster in dev environment, and then your developers are testing your data. Every time they want this good sweet spot where they want to test their applications. When they're testing it, they use some data and they do scrubbing some data, and everything data happens, right? And then if you want to go back in time, you can go back in time, and then developers can test their applications again. So you have two use cases for the Aurora backtrack feature. Any questions here? Okay, so, and then other future high availability concept is crash recovery. In traditional systems, if you're doing a crash recovery, you need to do redo and undo process, right? That takes, if you have a very long running transaction running before the crash, it will take a while to come up to the before you connect to your Aurora cluster. It will take a long time, because it has to go through redo and undo process. In Aurora, we don't have that issue. We don't need to do redo, because Aurora has a capability in the compute node. We have a process which can tell, right, whenever we're writing data, we also keep track of all the storage nodes. What are the storage nodes has what kind of LSN number, and until which LSN number is data committed, and until which LSN number above those LSNs data is not committed, there is a process which tracks about all these things. So in case of a crash, that process will tell the storage system that until this point, bring up your databases, and then rest of the LSNs, it simply discards it, because we do know that they are not committed in the data in the storage subsystem. So your recovery of the databases are really fast. And then here in traditional systems, you have only one storage node. You have to go through all the storage subsystem. If you have 5 terabytes of data, you have to scan through all of it. In Aurora, there are spans across multiple storage nodes, so it can parallelly do the things, and then it will speed up your crash recovery process. And then failovers in Aurora, how does the failover happens? What is the failover mechanism, right? So you have Aurora, from the storage point of view, you have high availability. I have seen some customers using just only one node, one writer, and then they think they have the high availability for their applications. So unless if you have at least one reader, you do not have a high availability in Aurora. It is not a multi-AZ, right? So from the data point of view, you have, but from the compute, from the application point of view, at least you need to have at least one reader in your Aurora. So that the reader can act as a failover targets for you, and then you have cluster endpoint that is always points to the writer. In case of a failover, it can automatically detect the new writer, and then your application will redirect the traffic to that new writer. So that's how the failover happens, and then you can also, if you have like more than one reader, right, you can also tell Aurora which is the reader I want to use it as my failover target for my writer. So you can configure that too. So you have a priority. 0 means highest priority, and you can have up to 0 to 15. So if you have, in this example, I put this as a 5, right? 5 means 0 is the highest priority, so 5 is the lowest priority. So in case of something happens to the writer, it will go to the highest priority reader node. So that's how the failover happens, and then you can configure which reader to be your next writer as well. And then normally the failover time, you would see normally 1 to 2 minutes, you would see the failover. But you also have a lot of other things you can do. You can increase that failover, you can decrease that failover time from 1 to 2 minutes to a few seconds. I will talk about those as well. And also you have, for high availability point of view, you also have a concept called multi-master, Aurora multi-master. So Aurora multi-master main thing is it will give you continuous availability of your application. For example, you have your application, and then in your Aurora cluster, you configured your Aurora cluster as a multi-master. That means you have more than one writer, and you can push your writes between all these writers, right? In case there is something happens, your transactions are aborted, and then connections are terminated because master 1 went down, because there might be some issue with the with that compute, or it might be going through a maintenance, right? Or maybe you might be so whenever there is a compute going through maintenance, or there might be a network communication issue, something happened to that, right? When it happens, you don't see any impact of your application at all. It can continuously writing using other writers you have, and then operate as before without any impact of your databases, right? And then when the action is, because we, as it is a managed service, we will detect that failure, there is something wrong with this master, and then we repair that master. Once we repair that master, we will redistribute the connections to the repaired instance. So you have a capability to use multi-master for high availability, so that so that you can decrease that failover time 1 to 2 minutes if you have multi-master, right? So it provides you high availability. Any questions here?
Yes, so multi-master, it means you direct writes to different, in this case, to 3 master databases?
Correct. So 3, yeah, in this example, what you see is 3 writers. There are no readers, right? So you just have writers. In multi-master, you don't have readers concept. You have only writers.
So how you avoid some conflicts if you have requests to update the same data?
Yes, so that is the conflict resolution you need to worry about. You need to shard your data, you need to make sure sharding is properly and your schemas are distributed properly. So that we need to take care of it. So if there is a conflict, then your application need to be aware of that conflict, because we will throw an deadlock error. So whenever your application detects that error, then it has the capability to resubmit those transactions to redo it again.
So application needs to be aware of
Correct.
conflict possibility, so it should be programmed.
Yes,
okay.
You have to have a retry mechanism in your application logic, yes.
Thank you.
Mm-hmm. And then we also have a concept called database, global databases. That means right now we looked into one region, right? So with global databases, you can scale your reads between the different regions. There are a few use cases, right? One is DR point of view. You want to keep your DR data into totally a different region, different parts of the world, right? You can use that as a DR purpose, and also you can use that secondary region cluster for your read traffic. If you have customers there, you can, if you want to distribute the load of your reads, you can do that too, right? You have that capability. So the replication lag between the regions would be less than 1 second. So if you're doing heavy system, your lag between the regions is less than 1 second. Is quite a good good achievement for the Aurora, because how we did is we did a storage level replication, not the normal traditional transaction logs process, binary logs. We did not ship the binary logs and replay those transactions. So it all happens at the storage level. We send the redo logs to the secondary region. But in this case, the only thing is we do not do automatic failovers to the other region in case whole region goes down. So you have to manually fail over, because whole region goes down. That means your application in that region is also went down, right? So you have to manually fail over to the other region. How would behind the scenes, what we do is in the Aurora global databases, Ohio is the primary region, and then you have other regions as your secondary region. Whatever you write on the master using in the primary region, we take those redo logs, and we have an inbound replication agents out there which will push those redo logs to the storage subsystem, and then the read replicas as well, because we need to update the read replica cache as well on the secondary region. So that's how we do it. And then we have seen high throughput up to 200,000 transactions writes per second without any impact of your application in the primary region by doing this technology. And recovery time is less than a minute. So because the amount of time it takes to fail over, manual failover, once you fail over, you would see within less than a minute your secondary region is up and running, but you would lose your data point of view. You would see less than a second data lag. So, and also recently, very recently, we have launched write forwarding feature. What it means is on the secondary region, you can write it as well. Here on the read replica also you can write it. But what we do is whatever you write here, that will be forwarded from the secondary region to the primary region, and then it will replicate back to your secondary region. So whenever you use write forwarding feature, you may need to aware that there will be a round trip of latency you might see, so that some cases, some customers use it. So if you have any of the application workload which you can adopt, which you can bear that write latency for the round trip, then you can happily use the write forwarding feature as well. Any questions here? Okay, so another feature in Aurora for high availability point of view is the cache MySQL caching, right? In case MySQL process dies, you still have your buffer cache warm. So we do not flush the buffer cache, so that whenever the server comes up again, you still have the cache for you, so that you don't need to start from the empty cache, so that you don't need to do physical go to the Aurora storage and bring the pages to the caching at all. So we decouple that caching for the and the MySQL process we decouple those two processes, so it's not dependent anymore. So in case of MySQL deprocess dies, whenever application comes up again, it still have the cache so that your performance is not impacted. So it will provide you better availability for your applications. And we also have Aurora proxy. So if you're coming from MySQL community, you would see a lot of proxy servers we use, like Proxy SQL, HA proxy, and all these proxies available for you. So Aurora in RDS as a service, relational database as a service, we have a proxy. This is not specific to Aurora. You can use it for RDS MySQL, Postgres, or any RDS engines. You can use it. So there are two use cases with this proxy, which will provide you high availability. First is connection pooling. So if there are any stale connections you have on the Aurora cluster, we will close those connections for you so that we will, because each connection requires memory and a CPU, right? So we will, it can act as a connection pooling for you. And also we talked about from master to, if we are failing from master to the read replica, normally the failover time is 1 to 2 minutes, right? If you use a proxy, right? Proxy can detect those failovers even quicker than normal traditional DNS update failures. So what proxy does is in case of a failover, proxy will go ahead and query all the readers and see which is the next writer, and then your application will start connecting to that Aurora cluster as well. How it looks like is, so before I talk about is, right, you create a proxy in front of the Aurora cluster. So your applications now connect to the proxy instead of connecting to the Aurora at all. So so all the communication comes from the proxy, and everything you can encrypt as well. And proxy, you don't need to manage those proxies. We fully manage those proxies, updating them, patching them, and fully managed proxies available for you. If you take your third-party proxy, right, you have to manage those. But in RDS, we take care of those proxies as well from the management point of view. So normally it looks like this. So you have application, you have Aurora cluster. In case of a failover, RDS proxy will point to the reader. Now it becomes the new writer, right? It can bypass the DNS. So that way it can increase your application availability 66% faster. That's what we have tested it, and we have seen RDS proxy is really one of the high available solution for your applications. So that concludes my high availability. Are there any other questions from high availability point of view? Okay, cool. So we have management and monitoring. In the management and monitoring, before I talk about how Aurora does in a managed services, right? I'm going to show you how 3 stages looks like. So in the first stage, you would see databases running on-prem. So you are responsible for the hardware, OS, and then DB softwares, backups, and setting up high availability, and you have to manually set up all those things, right? You have to do scaling operations, you have to do monitoring tools, you have to do configuration and everything. And then you will do application level design considerations, application performance, right? But if you move your databases into databases on EC2, we only give you physical hardware and OS installation, but rest of the things you have to do it by yourself. It's just like you have full control of your machine, right? Rest of the things you have to take care of it. But when you move to managed service like RDS, right? What we provide you is we provide you physical hardware, OS installations are done, DB installs are already done for you. But patching wise, you still have as a DBA, you still have to do the patching. For example, you choose to do manually because normally all the customers I have seen, they manually do the patching because they have to before they apply the patch, they want to test their applications, right? And you have to take care of the backups. These are all the shared responsibility models: scaling, monitoring, and tuning, right? So let me show you quickly all these, how they looks like, right? So when you talk about tuning and configurations, In Aurora, we provide parameter groups where you can set your SP configure kind of configurations in the parameter groups. And also, we automatically size the parameters for the instance class for you. And then you also, if you change any parameters, we audit them for you. So if you do on-premise, you don't see that capacity. So because you just simply change the config file, you don't have the auditing capability. Your responsibility is to tuning and customizing those parameters as per your application needed. So that's, and other thing is, from the monitoring point of view, we provide built-in monitoring and health checks to operate the service, because we have built-in processes or which monitors your drives, which monitors your compute, which monitors the network for between the compute and the storage. If there is anything, the health checks will take care of it. From the database point of view, we will provide you CloudWatch metrics, enhanced monitoring, and then performance insights. And then you also have capability to alarms and notifications, like normal DBA world, we set up an alarms and notifications, right? You have the same capabilities as well. And also log collection and publications, right? Publishing capacity. I will show you what that means, right? In MySQL, logs are totally different if you're coming from MySQL, or if you're coming from SQL Server background, right? I will show you how they're different. But in this, in the shared responsibility monitoring point of view, it is your responsibility to leverage these CloudWatch metrics, enhanced monitoring metrics, right? And performance insights. So looking at them, setting the alarms, what is the right metrics for you for your particular application. So you can set up the alarms for those, right? So that is your responsibility. And then we have a lot of logs, I told you. You can push all those logs, like for example, slow query log, general log, audit logs, right? Because you have auditing features, you may want to do it because you have auditors which require some auditing logs. So you have to analyze all those logs. We provide all those logs, but you have to manage them to push it to S3 or push it to a CloudWatch logs. That is your responsibility to do those. So I talked about logs, right? So CloudWatch, what it does, and quickly I'm going to go over. So CloudWatch will give you CPU, memory, database throughput limits, latency metrics. And CloudWatch logs can have error logs, audit logs, and slow query logs, and centralized logging. This is where you can push all your logs to the CloudWatch logs, where you can run queries on these type of logs too, if you want to. And enhanced monitoring will give you 1 second granularity of your metrics. For example, if you're troubleshooting an issue, right? You want to know at that particular second, how much is my latency? If you see in the CloudWatch, that will give you 1 minute granularity. In enhanced monitoring, you will get 1 second granularity of the metrics. And also you will have voice level process metrics also in enhanced monitoring. You can see which process is doing how much memory and CPU kind of metrics as well. That is the difference between CloudWatch and enhanced monitoring. And then performance insights, I'm going to walk you through the performance insights. So that is one of the important piece I want to show you. So performance insights basically give you a detailed view of the workload, what you're doing. So why do we use performance insights is to find out one of your top SQL queries and what are the wait types for your those particular queries, and which host is sending those queries to us, and what user is sending those queries. It will give you detailed information, and you can drill down into this particular graph and then tell what are the wait types, what is the main bottleneck of my query to run slow. You have that granularity to look into performance database loads. And also in MySQL, we have a concept like you can see how many number of inserts, updates are happening. Engine level metrics also you can see. So in the engine level metric counters also you can see in the performance insights. Normally, these performance insights are free for 7 days. I always recommend customers to enable this because it will really good tool to troubleshoot your wait types and any bottleneck of resource bottlenecks you have, right? So That is performance insights. And I said there are quite a kind of logs in MySQL. So probably this is something new you may learn today. So error logs are there. These are general error logs like SQL Server has. We have a slow query log. When you enable this slow query log, you can tell Aurora MySQL that I want slow query logs which are running more than 3 seconds or 5 seconds or 1 second. So whenever you configure that in your parameters, right, in the slow query log, you would see all the queries which are running more than 3 seconds, so that you can take those queries and then you can sit with your developers and then you can tune those queries. So you can improve the performance of the application. And then general logs is just like how we have a trace. It's the same way MySQL has general logs. In the general logs, you would see all the activity which is happening on the Aurora cluster. And we have audit log, auditing functionality, where you can see who is connecting, what kind of queries are there, and query events, data control, like who has grant privileges. If someone changing the privileges, you would see all those data manipulation, DML kind of queries you would see in the audit logs. So you can use all these logs in Aurora as well. And all these logs are there, so you can capture those logs. That's why we have database activity streams. Whatever the activity is happening on this cluster, you capture them on the real time using Kinesis. Amazon Kinesis is a data streaming service. On the real time, you can do Kinesis streams, right? You capture those to the Kinesis, and you can put it in S3, or you can use some of the third-party integration if you're already using for your auditing point of view. And one more thing in the monitoring tools point of view is RDS events. In case there is a failover happens, we have a built-in RDS event notifications are available for you. Like for example, someone in case failover happened, in case someone whenever snapshot started or snapshot finished, or whenever there is a parameter group, or someone changed the parameter group without knowing you as a DBA, right? So you get all these things, notifications are there. So on these notifications, event notifications, right, you can set up an alarms, right? CloudWatch alarms you can set up, and then you can send a notification to your emails or pager, or you can do that so that you can do real-time analysis on your Aurora clusters. Any questions before I move on? Cool. So in the scaling point of view, we have Aurora storage can scale up to 64 terabytes, and then you have a read replica or a scaling, and you have a Aurora serverless. It is an on-demand compute scaling for Aurora serverless. So let me quickly show you, and your responsibility is for the read replica auto scaling, right? Whenever you need to configure the read replica auto scaling thresholds. So from the storage point of view, on the day one, you don't need to provision the hardware for your Aurora cluster. You just simply spin up the cluster and it will automatically scale up for you until 64 terabytes. And then from the read replica auto scaling point of view, we have, you can automatically scale the read replicas for you. So you don't need to worry about in case if there is too much read activity happening on your Aurora cluster, right? You can automatically configure to add new read replicas for you. The Aurora serverless is the serverless capacity. It is vertically scale your compute or your writers. So this is basically Aurora serverless is basically used for infrequent workloads or Devon test kind of a workloads. For example, on Devon on Saturday, Sunday, if there is no activity on your Aurora cluster, then you don't want to run your compute, right? You don't want to pay for those compute. So you can simply and simply scale down to 0 compute. So you save some cost on the compute point of view. So Aurora Serverless is, and you pay as you go pricing. So you don't need to worry about anything. So whenever you configure Aurora Serverless, right, you have a one pool of instances. So here we configure all the instances what you want for your Aurora cluster. For example, whenever you created Aurora cluster, I want 2 CPUs all the way up to 16 CPUs. So we create all those instances for you. Whenever your load is increasing, like number of connections or increasing your then we will detect that automatically for you, and then we will replace that smaller instance to bigger instance, or bigger instance. If there is no activity, then we will decrease from bigger instance to lower instance class. That happens vertically for you. From the database backups point of view, you have backups 35 days. You can configure backups. Whenever you restore a backup, we totally create a new instance. We don't restore it on the existing cluster. And then you can share the snapshots, those backups, with other accounts. For example, you have dev account and test account. And if you want to share your snapshots, you can do that too. And one of the coolest features I want to show today is Aurora database cloning. So database cloning is nothing but you can, on the same Aurora cluster, you can clone the cluster, and then you can use that cluster for your dev and test applications. Or if you want to do performance benchmarking, or if you want to do blue-green deployments, right? There are different use cases. So from the cloning also points to the same storage when you create the clone. So you don't pay for the storage twice, but once clone is created, it will diverge any of the activity you do on the production or on the clone. What it means is, so you have 3 data pages in your production. You created a clone. Those clone is also pointed to those 3 data pages. If you if you add a page in the clone, that means clone will now see 3 data pages from the production and the new data page from the clone. But production cluster don't see that 4th data page. So because all the LSNs, what you write on the clone cluster and then original production cluster diverge from each other. So some use cases would be do like blue-green deployments or dev and test. For your developers wants to quickly have a production data, you can create a clone to the cross accounts, and then you can give that clone so they can test anything on the different environments, right? And then other use cases I have seen customers using is you have a monthly or nightly analytical reports you have, right? You want to quickly run those reports because you don't want to impact your production cluster. Then you can simply create a clone and then create a cluster. So that is what I have from the management point of view. From the security point of view, from the Aurora, how much time we have, Steve?
Vijay,
Yes.
There is a question about clones. Do clone impose any overhead on the production?
No, not at all. So that is the beauty about the clone. There is no impact of the clone in production at all.
Okay, maybe some minimal, or you're saying nothing?
Nothing.
Okay. Okay, he's saying thank you.
Okay, sure. How much time we have, Steve?
You can go up to 9 if you want to.
Yeah, I have security concepts and then one more migration concepts. Those are 2 parts. So I have 15 more minutes.
Okay.
All right, 15, 20 minutes. So from the Aurora cluster security point of view, what we have is basically in AWS, right? We have a shared responsibility model. So we take care of the infrastructure, regions and availability zones, and then compute, storage, and databases, right? We give you the database. And then we provide the networking and software. But your responsibility is, and then for all these infrastructure, what we give you are already compliance, right? If you have PCI compliance, that already have a compliance already there. It depends on the region. We need to check, right? Because there are so many compliance we have, so many third-party attestations we did, and all those available for you already from the AWS point of view. Also, not only giving you compliance, right? From some of the applications require data point of view. Customer data, you have full control of your data. And then to connect to your databases, you need to make sure your application using SSL, data in transit, right? But we will give you all the tools for you to do those, but your responsibility is to do those. What are all the requirements you have for that particular application, like PCI or HIPAA compliance, whatever the compliance requirements you have, right? You have that, or you have to still follow those compliance from the application point of view and your data point of view. But we provide the tools, like you can do data in REST. So whenever you create an Aurora cluster, within a single checkbox, you can do high availability, you can do data in REST, you can do auto scaling, you can do cloning, you can do backtrack, whatever all I said, right? All the topics what we discussed so far, you can do it within a single checkbox. The encryption also from the security point of view, within a single checkbox, we will create the Aurora storage volumes for you with encrypted storage. So all you need to do is you have to choose that. So to do that data encryption at rest, we use key management service, which is another service in Aurora that is tightly integrates with Aurora. You don't need to worry about all those things, but that's what we are using, key management service, which will give you encryption for the Aurora storage. You can also use encryption in transit. For example, if you want to bring your own certificates, right? Some of the customers wants to bring their own certificates to do data in transit. You can do that. Whenever you bring those certificates, put it in key management service. Whenever you're accessing it, you access it using those certificates. So you have all those capabilities, data in transit, data in REST as well. So Aurora supports TLS 1.2, and even for your database users, right? You still have full capability to provide what kind of permissions your database user wants. So for example, from authentication and authorization point of view, right? You can authenticate using native MySQL credentials. And also we have an IAM service if you want to. So for example, whenever you create an AWS account, you have that user, right? Using that user also, that is an IAM user, or using that user also, you can still authenticate to your Aurora cluster if you can configure that. But IAM users has some limitations, like you can't do more than 200 authentications per second. But if you have a bursty application, if you think, like, for example, you have a serverless Lambda application, right? In your application, if you have a Lambda, which requires more than 200 connections per second, then you cannot use IAM authentication. In that case, you have to use native MySQL credentials. So you have those authentications available for you. And also we have tightly integrated with Secrets Manager. Secrets Manager, where you can put your username and passwords, because normally I have seen a lot of customers using their application usernames and passwords in a config file on a file system somewhere, right? You don't need to do that. You have a tightly integration with Secrets Manager where you put your secrets like usernames and passwords. Whenever your application connects to your database, it will simply do a single API call, grab those username and passwords and connect to your database. So you have all those capabilities as well from the security point of view. From the authorization point of view, you have MySQL users, you can grant, you still have, whenever you create an Aurora cluster, we give you one master user. That master user have the highest privileges. So as a best practice, I don't advise customers to use that master user. I will ask them to create their own users and grant what are the necessary permissions for those users required, just like how we do it in SQL Server users, right? So rather than using SA for your production, use some other users, create a different user, clone master user, and then use a different permissions. You have all those capabilities as well. But in Aurora 8.0, you have a role concept, but it's not there in MySQL 8.0. You have the role concept, which is not there in Aurora yet because Aurora is only compatible with 5.6 and 5.7. So probably in future you may see that, but not at this point. And we talked about database activity monitoring. You can capture the audit log. This is one of the auditing requirement. I put this in the security as well because you can capture connect queries and then query DCLs, query DDLs, and DMLs. You can do that. Who is executing, who is including all those audits. You can capture those, put it into CloudWatch logs, and then you can do analyticals on top of those too. So this is also from the security point of view, you have those. So the last piece is how to migrate to Aurora if you're planning to migrate any of your workloads to Aurora. So there are few things. If you're already on RDS MySQL, right, then you can simply create a snapshot and then you can restore the snapshot as an Aurora cluster. That's simple as it. And also you can create from RDS MySQL, you can also create a slave for the replication, right? With a single click of a button, you can create an Aurora cluster as a slave to your existing RDS MySQL instance. So you have two ways you can do that. One is take a snapshot, restore it, or create Aurora as a slave to your existing RDS MySQL. So that's available. That is if you're on RDS already, right? So a lot of customers are not on RDS. They are on-prem MySQL they're using. If you have like on-prem MySQL, you can use tools like backup and restore tools like Percona Extra Backup. You can take the backup using Percona is one of the company which has extra backup software. You can use that software. You can take that Percona Extra Backup. We did some changes to that backup because it has to create a Aurora cluster. So we have some integration with that Percona Extra Backup. So you take that Percona Extra Backup when you have to restore it. When you restore it, you have your Aurora cluster. So from your on-prem, take a MySQL backup. It's just like how we take SQL Server backups, right? So same way you take the backup and then you restore it. After you restore it, you need to make sure that you have to also bring your users, accounts, passwords, stored procedures, and functions because our Percona Extra Backup does not include all those things. If you have a database bigger than 1 terabyte, rather than using a normal traditional MySQL backup and restore, MySQL dump and MySQL load tools, use the Percona Extra Backup. This is the best tool I have seen so far. It can easily create an Aurora cluster for you. And that's all I have. If you're coming from SQL Server or Oracle, right, you have a capability to use database migration service, and then that database migration service will migrate the data from SQL Server or Oracle to Aurora MySQL. So for that, you need to create an empty Aurora cluster and then use database migration service so that we can move the data from SQL Server to Aurora MySQL. So that's all I have for today. If you have any questions, feel free to reach out to me. I'm happy to take any questions if you have any right now. I can.
No, thank you. It's quite a lot to digest.
I know. So there's quite a lot. It's not that you need to learn everything today. You just need to know there is something exists, technology, something like this, right? There is something new. Um, I want to show you today. I should have done pretty small, but what is the point, right? If you don't learn something.
So it seems like the biggest difference in Aurora is the storage. This is layer shared clusters.
Yeah, storage, backtrack, cloning, and then
Yeah, but all this backtrack cloning, it's all because
on top
of
of the storage
because
layer.
of the storage,
Yes.
right?
Correct.
So the storage layer, it's the most interesting.
Yeah,
So,
and Aurora serverless you have too, right? And then AIML integration. There are different features you have available, but most of the features what we talked about, like multi-master, global databases, cross-region replication, less than a second, all those things, yes. Design of the storage, how we did.
so basically, storage layer is it's not hard disks, it's not S3, it's basically
Log structure.
it's a fabric. It's like a system, right? That says some processes underneath, something something going on right there.
Exactly.
Something applications.
That's correct.
And when you're talking about like like I just want to just understand better. So for example, in regular database, we are talking about like how you call it, like two-phase commits, something. So you write to the log, you write to the data, you write to the log, something like this, right?
Yes.
In this case, you just write once, right?
That's correct.
So you just say, hey, write this, I change the value like
this to this, A to B, right?
Yeah, A to B, I change this just one field, right? And you change this in the cache, right? And right away, you don't have checkpoint. Right away, you say, write this change to the storage. You just get API call, whatever, right?
That's correct.
So, and after that, the magic happens in the storage layer, right?
That's correct. So that's why we moved that logging layer to the storage.
Yeah, so underneath what the compute doesn't see, it's happening. You basically write to the redo log, right? And then you understand where the data resides, and you write to those data nodes, right? And you something similar like HDFS system. You understand where these blocks needs to be duplicated in which, so it's all going like different life going there, right?
That's correct.
Okay. So you basically don't use this compute resources for this, what's happening underneath. You use in other compute resources, we don't pay for this.
Correct. And because we, even though maintain 6 copies, you only pay for 1 copy.
Right. And in another write is going parallel to the cache on a different readers, right?
Yeah, the reader will act as a high availability for you. Yes, that reader acts as a failover target for your master.
So when you do change one field, you're writing to local cache, to the storage, and you send information to the cache to all readers.
Correct.
And all of this cache on other readers, they have all different cache depending on the usage, right?
That's exactly correct. So if you have different readers, you can point your different applications to those read replicas. They might have a different cache. So you don't need to always update all the caches. Sometimes you don't need to update. In that case, we simply discard that read log.
Yeah, so if this field's not in cache on the reader, it just throws out.
Throws out, yeah, that's perfect.
Okay. That's a little bit clear.
What about tooling? So something like Manager Studio.
Oh, yeah. So for connectivity from the developer point of view, you have quite a lot of open source tools. You have like MySQL community tool called Sysbench tools you have, right? Let me say DB visualizer you have, and then MySQL Workbench tool you have. You have quite a lot of tools. Sometimes normally customers use, I have seen, using an compute Linux machine to connect to MySQL using Linux. So, but from the visual graphic point of view, you have MySQL Workbench you have, and that is one of the popular one I have seen. And then DB Visualizer is another tool. DB Visualizer just exactly looks like SQL Server Management Studio if you want to explore.
Got it. And from the tooling perspective, they wouldn't know that, they wouldn't feel any difference between RDS and Aurora.
Correct. So
okay.
It doesn't matter. Yeah, it's just the tool. So behind the scenes, it's just like how you normally use MySQL. You can use Aurora as same thing because it has a drop-in compatibility with MySQL.
Got it. Well, I have another feedback for you saying nice presentation. Thanks for a great overview.
Thank you.
And another question, you mentioned like 4 logs for Aurora that's available. Are they written in the same cluster, or are they written in separate places where they live, basically?
What is that question from?
Like logs, like slow query logs.
Okay. Yeah.
General logs. Where are they written somewhere, or they send right away to the?
You can configure them to write it on a file, and then you can download it, or you can configure them to send it to the CloudWatch, so you can access from the CloudWatch, or you can also query the CloudWatch those logs.
So those logs, it's not in the shared cluster layer. They separate on S3 or CloudWatch or somewhere else, right?
Correct. So if you want to put it in the Aurora storage, you can do that too. If you don't configure that to as a table, then you can put it in Aurora storage too. But I don't recommend that because you don't want to write quite a lot of heavy things on your Aurora storage. I always recommend to push them to CloudWatch as the files.
Okay. Thank you very much. It was a really nice presentation.
Thank you.
Again, I have another thank you, and thank you very much for the great presentation. So sounds like you receiving great feedback.
Thanks.
Without
Thank you.
us falling for the feedback.
Yes.
Thank you. Have a good day. Steve, you have anything for me, or can we end it?
Thank you for presenting, and thanks to all attendees joining the session.
Thank you. Bye.
Thank you. Bye-bye.